I am Dan Cecil. I'm the offering manager for renewable fuels here at Honeywell UOP. Eco-fining is a process to convert vegetable oils and animal fats into renewable diesel and jet fuel. It's a process that takes the oxygen out of those feedstocks and converts them into a chemical form that chemically resembles petroleum diesel and petroleum jet fuel. So the big trend in the market today is around refinery revamps. Petroleum refiners are examining their day-to-day operations and looking for opportunities at different refineries to incorporate the processing of renewable biofuels. So they're taking assets at the refinery that may be underutilized and converting them to more profitable operations for the production of renewable diesel and renewable jet fuel. Because all the vehicles are mobile by definition, creating low-carbon fuels to be able to reduce the effects of petroleum fuels is a main focus of the overall targets for reducing carbon emissions. Honeywell UOP is focused on expanding the selections of different feedstocks that are available to be processed through our technologies. We take this as a very important focus of our future development programs and think that this is what the next generation of technologies will be based on.
Hi, my name is Patrick Robinson of the Phillips 66 Bay Refinery. Myself and Atik Malik will be the facilitators of a two-part series around the future of advanced process control. We're extremely excited for these sessions as AFPM was able to bring in all the main players in the field. These include long-term providers such as Honeywell, AspenTech, Aviva, and Emerson, and the new entrants such as oPRO. APC technology has certainly matured over the years, and most efficient facilities use it. However, there are several important changes that have taken place both on the personnel side at the site, sometimes new and experienced, less employees, and there are new emerging technologies with limited papers or university engagement regarding the subject. This session arose from the need to assess these needs versus the technology of the market and the direction in which it's headed. Before presenting, we've asked these vendors questions organized into 4 categories, going from people issues, training, base technology, and the maintenance of these controllers going forward. These questions, these slides, and the recording will be posted on the AFPM website and available for all users.
Hello. Thank you for attending. Today I will be talking about our technology in oPRO that we use and develop at oPRO.ai for the application of deep learning in real-time optimizations and advanced process control. We have done very good work in different facilities, helping our customers to use this technology with our platform. Could we go to the next slide, please? So this is our approach. We have a deep learning platform which has multiple machine learning and deep learning type of modules that can be configured easily. And with that, basically, we get data from the process or the plant or operation. We get the constraints from our users, whether they're going to be the min and max values for the constraints, the moves, etc. In order for us to use AI effectively and to automate the process to be more efficient and to take the best action. So that we want to bring AI in a way that is easily consumable, that can provide value for sure. Could we go to next? Yeah. So as we move into this Industry 4.0 the transformation of the business to be more automated, we see that there are challenges. So there is a lot of data, right? So data come from very different ranges, right, of operation, incomplete data sets, typically because some data is not as frequently measured, such as lab data. But still, we want to develop models that capture that dynamically. We have inconsistent information and complex relationships. We have different constraints, and also the amount of specialists in the plant, there's not many. So we need to make to provide this technology so that they can expand and they can deploy faster projects with more value to their companies. Could we go to next? So in essence, what we do with oPRO.ai is that this platform gets data from the process or plant, from all data points, high frequencies, frequencies that is needed, And we take that information to build a state model that will capture the dynamics of the process. So we will be selecting basically what is the best machine learning or deep learning model that will capture correctly the dynamics of the process. Is it that either an APC or RTO? We will also look at the different constraints, the emission constraints, flow rates, mechanical constraints, everything that is needed. And then we will build this dynamic model. This dynamic model will capture all of the inputs versus the outputs, and all of the, in terms of APC terminology, right? MBs to CV relationships. Basically, what we do with AI is to take all of the data from the different comfort zones of operators. Operators are operating the plant at in different ways based on their knowledge. So basically, out of all of those comfort zones, we can extract the best information to run the plant optimally, and that's our approach. Could we go to next, please? So our platform allows to get data from different systems. We can get data from the historian. Typically, when we are training the models, we can get 1-2 years of data and create a model with that. Time series systems, structure on structure information into the platform. Of course, when we are running in a closed control loop, we get the data from the control system using OPC. And then the platform has basically a backend that allows the testing, the training of the models to develop continuous learning models, so that if we need to retrain a model, we can do it. And then all of the optimization modules. Then in the front end, we provide for the operator the dashboards and also the HMI that is needed for the operator, and we can deploy this platform either on cloud or on-prem, as depending on the needs of the customer. Could we go to next, please? So in a nutshell, basically we build a model with all of the inputs, all of the variables that are going to be impacting our CVs. Of course, the model can be as complex as multiple models assembled into one large model. It could be a regular recurrent network. It could be an LSTM that is basically tested when we're building the models, just to find out which ones will be the best to use for a specific case. And then we use search, stochastic type of search, to find the optimum values of the MB moves in order to either maximize certain variables, minimize other ones, or keep it stable, depending on the objectives of the multiple objective problems that we want to solve. Could we go to next? And in order to facilitate this process, we provide a tool. We work with APC engineers. So we collect the data all of the tags from MBs, DBs, right? All of the data is collected. We get the data from the process data historian. We automatically create data checks, data validation. So we have all of these programs that allows a fast check for the data quality. Once we have completed that process, we are ready to develop the algorithm or algorithms, and then deploy the system initially for open loop, and then later for closed loop operation. Could we go to next, please? So something that is important for APC engineers, so when we talk about AI, is that people don't want black boxes. They want to understand what the model is going to do and when the model is going to do a certain action. So in order to do that, first we perform correlations with the different AI machine learning models. We look at the predictions, the quality of these predictions as well. And then we can also run simulations holding, let's say, moving one MB and look at the response of all of the outputs while maintaining the others MBs fixed. And then we look at the responses. We look at the gain. What is the steady state gain? All of that information helps because then the APC engineer knows that the solution is going to be doing the right thing for the when we are going to be violating a constraint or we want to approach certain value. Could we go to the next slide? So this is what you typically see when you apply deep learning, right? So you, instead of having a gain graph, gain curve that is just one line, here you get n number of lines. So this is a family of curves because the system is learning the dynamics as a function of the other state variables. So here I'm saying low, medium, high capacity. So here you're seeing, let's say, the response of, let's say, opening a valve and the temperature in the reactor, right? So that's what you get when you learn the dynamics, that you just don't only get one curve, you get a multitude of curves. And then, so in these ways, we can optimize the model better. Could we go to the next one? Yes, next one. Yeah, and of course, also, we present all of these predictions to the customer. Then later, as I said, once we have good predictions, a good valid model, we perform optimization, like I said, using genetic algorithms, stochastic models, and then we are able to deploy the solution, right? So this is our presentation for today. The presentation will be available. I have multiple slides with information. For example, here, this is where we have the pipeline, right, of the different algorithms. Here I'm saying I'm getting data from a historian, then I will apply filtering, remove outliers, train with an LSTM, do an optimization with a stochastic algorithm. All of that can be is plug and play, and this complexity is hidden for the user. The customer that is using the end solution is just using that HMI. But all of that, a platform allows the development of very fast models. So, well, that's the end of my presentation, and thank you. Thank you so much for listening, and I will be glad to talk to you later and go deeper into this topic.
All right, thank you guys. Please join us in the lounge, the virtual lounge, under the optimization and planning. That's room F, and you can get the link from the screen on the chat, and you're able to ask all these amazing presenters some further questions. And with that, thank you for coming into our APC of the Future Part 1 and 2, and I'll see you in the chat. Bye.